Hi folks, this video is for class on Tuesday, April 14th. We're going to talk about using the t-table in this video. I'm in section 13 of the notes and section 13.2 of the textbook. All right, so I just wanted to take a second to look a little more carefully at this t-table at the back of the book so you understand how to use it. So you'll find this in the back of your book. It's somewhere in the appendices in the last 10 or 15 pages or so of the book. So you should find that and throw a bookmark in there because you're going to be using it a bunch. All right, so we've used this already when we dealt with confidence intervals. And when we dealt with confidence intervals, we generally started up here at the top of the table to find the confidence level we were interested in. When you deal with hypothesis tests, the first thing you want to do is actually go to the bottom of the table here. And what you'll do first is pick out whether you are working on a one-tailed or a two-tailed test. Remember, a one-tailed or one-sided test is when the alternate hypothesis is that mu is bigger than or less than mu0. And a two-tailed test is when it's the not equal version of the alternate hypothesis. Then what you do is identify in this row your value of alpha. And you'll notice that the values in the two-tailed test are just, pardon me, twice as big as the ones for the one-tailed test. All right, so let's say we're doing a test with alpha equal to 0.05, and let's say it's a one-tailed test. So I'd locate my alpha value in that one-tailed row, and that tells me that I'm going to be working in this column of the t-table. Next up, we have to use our degrees of freedom, this df number. And remember, for these tests, the degrees of freedom depends on the sample size. It's the sample size minus 1 if you're just doing a single population mean. So let's say we had a sample size of 20. So in that case, if n is equal to 20, then our degrees of freedom, 20 minus 1, is 19 right here. So that tells us that we're going to come across this row to collect our data. Those intersect at 1.73. And this is a little different from how the z-table worked. In the z-table, you would have looked up a specific z value and then found your p-value directly from that. What we can do in this situation is the following. If when we do our test and we calculate our value of t, if that's greater than 1.73, then our p-value is less than the alpha, in this case 0.05 that we're working with. If, on the other hand, your calculated t-value is less than 1.73, then your p-value for this test is greater than alpha. So the question is whether this t-value is bigger than or less than 1.73. Let's change that to correct it. And then one final thing to point out here, we also sometimes will get negative values of t, right? If the sample mean is smaller than the null hypothesis mean, you'll get negative values. So what you really want to do is not just look at the value of t, but look at the value of the absolute value of t. So make the number positive and then compare it to this number that comes from the table. If it's bigger than that number, then your p-value is smaller than alpha and you can reject the null hypothesis. If your absolute value, if your positive version of t is smaller than the number you find in this table, then p is greater than alpha and you don't reject the null hypothesis. Okay, so that's the general idea of working with this table. Let's do an example and see it in practice.